Rooms are alive, the sound of music, because Julie Andrews' voice is something special.
Hello, everyone. Thank you for joining us today. My name is Kara Gordon. I'm the Partnership and Communications Coordinator for ECU's Center for Sustainable Energy and Environmental Engineering. I'd like to welcome everyone today to the first of 3 webinar events in our Fall Pollution Prevention mini-series. Our mission at the Center is to promote renewable energy technology and natural resource conservation through scholarly and applied research in an effort to enhance industry awareness and best serve North Carolina communities. With research funding through the EPA's Pollution Prevention Program, center students, faculty, and affiliates provide valuable resources to businesses and industries across North Carolina. We offer energy, P2, and lean assessments and training largely to North Carolina automotive, chemical, fabrication, and food and beverage manufacturers. After conducting a facility assessment, the center additionally provides technical feedback and various business analyses. We also facilitate certification workshops for sustainable and green manufacturing. On October 13th and 27th, we have our 2-part Lean Six Sigma White Belt certification workshops. If anyone's interested in this workshop, please contact me at sustainabilitycenter@ecu.edu for further information. So before I introduce our speakers, just a little housekeeping. We'll be recording today's event. Again, please contact me at sustainabilitycenter@ecu.edu for access to our shared library. You'll also find our speaker presentations in that shared library, and they're also uploaded here on the Teams platform. If you have any problems, just let me know. We encourage you to interact with our speakers today. We'll take questions at the end of presentations, time permitting. After the webinar, you'll receive a follow-up email from me asking to provide feedback. Please take a moment and tell us how we can improve our events. The email will also provide a link to donate to the center, and we gratefully accept any donations, large or small, as they help us support student activities, travel expenses, and community engagement. So with that, I'd like to introduce our first speaker today, Dr. Jinkun Lee. Dr. Lee is an assistant professor with the College of Engineering and Technology at East Carolina University. He received both his undergraduate and graduate degrees in aerospace engineering from Seoul National University in South Korea before receiving his PhD in industrial engineering and operations research from Penn State in 2014. His work experience includes new car development with GM Daewoo and gas turbine engine design and testing with Korea Aerospace Research Institute. His educational resume includes graduate and undergraduate engineering courses at Penn State and Binghamton University before coming to ECU, where he teaches analysis of production systems and facility design. Thank you, Dr. Lee, for joining us today. Next, we'll hear from Dr. Merwan Mehta. Dr. Mehta has over 20 years of industry experience prior to joining academics, including VP roles, manufacturing and project management, industrial and machine tool design engineering, and business ownership. His involvement with Lean Six Sigma process improvement helps businesses become more productive and profitable. Dr. Mehta's current research interests includes enhancing manufacturing and business processes through lean principles and theory of constraints, and the pursuit of quality and variation control through Six Sigma. He conducts subject matter workshops both nationally and internationally. So thank you, Dr. Mehta, for your time with us today. And now with that, I will turn the platform over to Dr. Lee.
Okay, thank you, Kara. It's my pleasure to talk in the webinar series in EPA. I'd like to talk about the lean manufacturing in automotive industry in particular. So, so decision about how goods such as food, the plastic packaging, and building materials are produced, transported, used, and disposed can make a big difference in the amount of the resources used, and greenhouse gases emitted, and environmental impacts created, and waste produced. The greenhouse gas, in abbreviation GHG emissions, and other environmental impacts associated with goods result from the energy, land, and the water used to produce and transport and consume and dispose them. So according to the Global Resources Outlook 2009 report from the United Nations Environment Programme's the International Resource Panel, up to half the global greenhouse gas emissions stem from the extraction and processing of the material and fuels and food. Therefore, reducing, reusing, and recycling and composting are strategies that can lessen the environmental impact of goods. There are many case studies we can access free based on our need for specific business processes. This ad hoc case study information will save your time and effort to develop your idea how you can make your process lean. The link under this slide is from EPA government site for your reference. So EPA also creates the waste reduction model in abbreviation WARM to help solid waste planners and organizations track and voluntarily report greenhouse gas emissions reductions and energy savings and economic impacts from several different waste management practices. So out of the whole list of material types recognized by WARM, I want to mention some of them in this slide, which are frequently used in the automobile industry. And this is a screenshot of WARM in Excel spreadsheet form, which you can download from the link in the previous slide. What you need to do is to identify the material type used in your manufacturing process and type in the approximate amount. And WARM application for Windows and Mac users are also available for free at the WARM website in the previous slide. So why we are talking about the lean? Basically, the lean approach in the manufacturing area is to reduce inventory level as well as redundant material use or unnecessary processes. However, reducing inventory level helps us not only reduce the budget binding to the purchase of unfinished material, also known as a work in process, but also identify many hidden problems which are usually not taken seriously until one-piece flow production level is achieved. It is due to the conventional wrong belief that high throughput means high performance. It is not true, since bottleneck rate is the real system performance. Overprocessing in any other stations besides bottleneck station is nothing but waste in reality. That's why we need to practice the lean. The lean manufacturing is a business model and collection of tactical methods that emphasize eliminating non-value-added activities, which is waste, while delivering quality products on time at least cost with greater efficiencies. In the United States, lean implementation is rapidly expanding throughout diverse manufacturing and service sectors such as aerospace, automotive, and electronics, furniture production, and healthcare as a core business strategy to create a competitive advantage. While the focus of lean manufacturing is on driving rapid, continual improvement in cost, quality, service, and delivery, the significant environmental benefits typically ride the coattails or incidentally as a result of these production-focused efforts. The lean production techniques often create a culture of continuous improvement, employee empowerment, and waste minimization, which is very compatible with organizational characteristics encouraged under environmental management system and pollution prevention. The other related business strategies such as Six Sigma can have the same impact. So in lean manufacturing, 7 wastes refer to 7 typical places manufacturers have waste. Using the 7 waste tools, manufacturers can determine where they have waste and can improve their processes in each area. The method was invested by Toyota in 1980s and is an integral part of the Toyota production system, and it's widely adopted in every sector of manufacturing and production areas. The first, the Kaizen, is the Japanese word for continual improvement. The term refers to activities that improve every function of a business and is generally applied to manufacturing, but can be used to make almost any business more efficient. In fact, the Toyota production system made the tool famous. If problems occur within the production process, Toyota assembly line personnel and their supervisors are expected to stop the production process and begin a Kaizen. And the 5S method refers to 5 Japanese and English terms that begin with spelling S and provide a workplace organization method. The first one is sort. In Japanese, seiri is decide which items in a factory are necessary and which ones are not, and get rid of the ones that are not. The second one, straighten, or is in Japanese in seiton, is make sure every item in a factory is in right place. The third one, shine, in Japanese seiso, is clean factory regularly by getting rid of dirt, garbage, etc. And the fourth one, standardize, in Japanese seiketsu, is create standards to ensure clean and neat factory floor. And the last one, sustain, in Japanese shichuke, is create habits that ensure standards are met over a long term. So these are originated from Japan, but it's common as the kind of widely adopted method, 5S method, to identify the waste. And next one is Pokayoki, was developed by also Toyota. The idea of Pokayoki is to prevent mistakes from becoming defects, mistakes. So it argues mistakes are inevitable, but defects that actually reach customers are preventable. So the goal is to create a form of quality control that highlights defects automatically and eventually take humans out of the equation. The tool was invented because of human error. The humans that perform repetitive manufacturing tasks day in and day out can very easily miss common mistakes and defects. So a real-life example of Pokayoki may be an alarm that goes off automatically when you leave a car without turning off the headlights. It will be kind of foolproof and error-proof. And Andon is a signaling system used in the manufacturing process. When there is any abnormality or some sort of important action is required, it is a form of visual management. In manufacturing, Andon lights are generally used in assembly lines, and different colored lights are used to signal different problems and actions required. And operators may turn on an Andon in order to signal that there is a problem in an assembly line, and whole assembly line will be stopped until the problem is fully investigated and resolved. So it's preventing producing any defects continuously without stopping the line immediately. And Kanban is the Japanese word for signal card. In previous decades, the manufacturing workers would fill out a signal card when a part was running low. The signal card would be sent to a team or employee whose job was to order more of that part. But today, this process is mostly computerized, and the idea of Kanban is to buy more parts only when needed. So the goal of Kanban is primarily to reduce the waste. If parts are only bought when needed, you are less likely to waste time, money, or space ordering unnecessary parts. And Heijunka is the Japanese word for leveling. Heijunka is meant to level the type and quantity of production while reducing batching. The Ford Motors was once known for manufacturing cars in batches, and Toyota used the Heijunka to minimize batching and create a more efficient manufacturing process. And Gemba is meaning the real place. In manufacturing, it refers to the factory floor. The idea of Gemba in lean manufacturing is that management must go to factory floor to search and fix visual problems. The manufacturing problems, Gemba argues, cannot be solved from an office. They require an actual physical presence by problem solvers on the manufacturing floor. And just in time, in abbreviation JIT, is a lean tool that calls for the production of what a customer wants, when they want it, in the quantity they want it, and where they want it. Instead of creating a large stock of product that sits in warehouses, you only create as much an item as a customer actually wants. This reduces unnecessary inventory and ensures that companies only spend on stock that will be paid for. And one-piece flow is the sequence of product or service through a process that is one unit at a time. The one-piece flow is the opposite of batch processing, where a large number of products are created at once and they are sent through the manufacturing process as batch or group. In one-piece flow, the focus is on the manufacturing of the product itself rather than the waiting, transportation, and storage of the product. And value stream mapping is a lean tool that uses a flow diagram to depict every step of a process. So the purpose of VVM is identify waste, reduce manufacturing time, and make entire manufacturing process more efficient. And data points to collect for VSM value stream map include inventory, number of operators, number of shifts worked, and batch size, time it takes to make one product, time it takes to switch from one product to another, and how much time factory can run. So the performers this is an example of table from the source from the Aberdeen group in September 2014. There are many different measures of the lean leaders and lean followers, but most of them, over all other metrics, the operational cost due to inventory management is showing big difference. The leaders are using only 3.6% of their expense in inventory, but the followers are using almost 10%. So we are in the now fourth industrial revolution, it's known as Industry 4.0. It is not simply a buzzword. It is affecting every sector and every business operating today. And the automotive industry is no exception. Industry 4.0 is an integration of the physical, biological, and digital worlds built on a basis of emerging technological breakthroughs, including autonomous capabilities, artificial intelligence, and the Internet of Things, and next generation wireless technologies, big data, and cloud computing. Some of these technologies in use already today on a mass scale or just emerging and being tested. So we still need to apply the lean concept in the new technology and its continuous improvement. So thank you. That's all I have to say today. My name is Jinkun and my email address is in the slide. So please feel free to contact me if you have any questions. Thank you.
Thank you, Dr. Lee. Again, we're going to take questions at the end of both presentations. If you are unable to speak to us, then you can drop your question in the chat feed and I can ask for you. Or if you just feel uncomfortable being on camera, either way. So at this point, go ahead and turn the platform over to Dr. Mehta.
Thank you very much, Kara. I'm Merwan Mehta. I am the coordinator for the Industrial Engineering Technology program at East Carolina. I also do Lean Six Sigma Black Belt. And I'm going to try and fill in some details that would kind of really enhance the presentation that Dr. Lee made. So
Dr.
if I can...
Mehta, I'm sorry to interrupt. Could you share your screen with us, please?
I'm trying, but I'm not able to. Okay, let's see. Okay, can you see my screen?
And there it is. Okay, thank you.
Okay, great. So I would like to start with where Lean started. So Lean manufacturing came into existence when there were three professors, and I show you the title of the report that they wrote here. The title of the report was called The Machine That Changed the World. And this came out in the late 80s. And there were three professors, Womack, Jones, and Roos. And that time they went to the US government and asked for a $5 million 5-year grant to study the future of the automobile. And that you can see on the cover of this report. And what they did was they went to 90 plants in 17 countries and studied all these car manufacturers. So manufacturers like Toyota and Honda and Mitsubishi and Subaru and all of those in Japan. And they also studied a lot of cars in Europe like Audi and Volkswagen and cars like those. And they also studied the 3 US manufacturers. And what they came through that was kind of really eye-opening. What they essentially said was that the Japanese seem to be doing something very differently that the US manufacturers and the others are not doing. And if the other manufacturers did not catch up to what the Japanese were doing, they're going to go out of business or they will be bankrupt. Now, this prediction they made in the late 80s when GM, Ford, and Chrysler, our big three, were doing very well. But we know what happened over time. All of them had to reorganize and restructure. And the gist of this report was that Toyota had come up with what was called the Toyota Production System, where they had collected a whole bunch of tools and philosophies that they were using that was giving them that distinct advantage in the marketplace. Now, as lean has moved on, lean has been applied in manufacturing, but there's a tremendous scope to apply lean in service also. And as service is 80% of our GDP, we have realized that the cost of services have been inflated by around 30 to 80%. So if all services are costing us 30 to 80% more than what they should, you can imagine how much savings can be achieved if we started applying lean in also the service sector. The whole gist of applying lean in the service sector is to accelerate the speed of all processes. And the central thought there is the customer does not have to wait. So in a way, think about when you go to a fast food place. The food might not be the best, but you can be rest assured about the fast service. And that's where the whole concept of lean has gone. How do you make sure that the customer does not have to wait? Now, the other thing that lean also does, especially for the service sector, is to reduce complexity. So reducing waste and reducing complexity go hand in hand. And as an example of reducing complexity, at the Stanford hospitals, there were 6 surgeons, and each of them had a different kind of a tray that they were using for doing surgery. Now, in improving the processes, one approach that they could have taken would have been to ask, okay, let us go and simplify these 6 trays so that all 6 surgeons are happy with the results that they get. But that is not the approach that you should take if you're going to apply lean and reduce complexity. What the question should be asked is, how can we make it more efficient by just having one kind of a tray? And so when you reduce 6 trays to 1 tray, you're going to reduce the complexity substantially. And that's what Stanford ended up doing. And in doing so, they were able to save $25 million per year in their hospitals. So there is a tremendous potential for reducing complexity using lean. So then the question becomes, okay, so what is the process of lean? The process of lean, as was later published in a book titled Lean Thinking by 2 of the professors that I initially mentioned, Womack and Jones, they said, okay, lean can be looked as 5 ideas to be pursued, one after the other. First is you define the value. Defining value is to see, okay, what are we providing to the customer and how can we provide it in the best possible manner? So really realize what the customer wants. The next is you understand and document the flow of value. What we mean there is, like Dr. Lee showed you the value stream map, what it shows you is how do you take the steps to create this value for the customer. Now, in a lot of cases, if you have a process and if you just create a flow chart, you will start improving the process, because a lot of times a process is being conducted without having any kind of a flow chart or any kind of a process that is being followed. The third item is what also Dr. Lee kind of covered there. Identify non-value added tasks and eliminate them. So those 7 wastes that Dr. Lee talked about is what you do in the third stage. So all work is either value enhancing or waste. And so our goal is to see how we can apply those 7 waste concepts and reduce all the waste in the process. Now, the fourth step is one of the most important, where you standardize the processes. And standardizing the processes means to eliminate complexity and do all processes just one way. And in doing so, what you're doing is you're trying to focus on what is called lead time and pull. Lead time is nothing but the amount of time that the customer has to wait, and pull is the system that allows you to make or get on with an output only when there's a customer who needs it. Now, if you are just going to apply one tool of lean that'll immediately start to give you benefits, think about standardizing your process. If you can just make this a rule that whatever process we're doing will be only done one way, and let us just all put our heads together and come up with one way, you will begin to immediately see substantial improvements in the way the process is being conducted. It's a very simple concept, very straightforward concept, but very, very difficult to implement. And then the fifth point is you strive for perfection. The idea there is keep applying these 4 over and over to other parts of the factory or other parts of the office. So lean is conquering complexity also, like I mentioned. Now, here is something that we have realized. Payoff of eliminating complexity dwarfs payoff from process improvement efforts. So what we are saying is complexity reduction can have big time savings, which not even your process improvement efforts will bring about. And that is why complexity is a kind of a great, complexity reduction is a great tool to pursue. And in this case, we need to also all the time see whether we are only introducing value-added complexity and not adding non-value-added complexity. So what is value-added complexity and non-value-added complexity? Value-added complexity is the additional requirements for different customers that we'll be putting into our product line, for which there is a true demand and we can have substantial revenue from those actions. Non-value-added complexity is evolved complexity or unexamined complexity that keeps coming into the processes because we are not constantly keeping an eye on how the process is being conducted. A process starts out as a very straightforward process. You have activity A, activity B, activity C. But then over time, when there are issues that come up, we tend to let the process evolve. And evolution of the process happens when you only have 3 activities, but then you say, okay, now let's start doing activity D and activity E and activity F, because there are some issues that are coming up in the other activities. Now, as we keep adding activities into the process is evolving, but we do not take the time to re-examine the process and redesign it. And that is where complexity comes into the process. As an idea, as some examples of complexity reduction cases, let's look at the case of Mitsubishi Machine Tools. Mitsubishi Machine Tools is a big corporation that makes these humongous machine tools, 6-axis milling machines and CNC kind of machine tools. And what they did was to reduce the complexity in their products. The president of Mitsubishi said that we're only going to use 6 fasteners in all our machine tools. Now you can imagine there are over 100, 200, 250 fasteners, but he said you're going to only use 6. And which 6? The president left it up to the designers to decide and said, once you have finalized these, we will only use those 6. Now you can imagine if you only are using 6 fasteners in all your machine tools, how that reduces complexity. You will only need 6 kinds of bolts. You will only need 6 kinds of nuts. You'll only need 6 kinds of drills to make holes for those, 6 kinds of taps, 6 kinds of wrenches, and 6 kinds of washers, and the whole thing kind of keeps going over and over. And you can imagine if you had only 6 fasteners, how much easier it would be out in the field to fix a problem that the machine tool has. The concept is similar to what Southwest Airline pursues. Southwest Airline, their marketing kind of policy is to use only one aircraft. They only use 737s. And for quite a while, Southwest was the only airline that was profitable, because imagine you are only having to look at one aircraft. You only need to store one kind of spare parts, one kind of engine. You only need pilots who will be able to fly 737s. You only can fly between cities, which can take a whole 737 in between the two. And so the whole list keeps multiplying. So complexity reduction is a big kind of a way to kind of go lean. Another example is of this International Power Machines. And in that, they were making these UPS systems from 5 kilowatts to 300 kilowatts. When they did their analysis, they found that there were no common parts between any of those products, and it used to take them between 6 to 12 weeks to deliver the products. After they did their complexity reduction, their gross profit went up from 18% to 37%, and the operating profit went from a loss of 3% to 20%. Now remember, this is just by simplifying their offering. So then the question becomes, okay, all this is there, all these tools are there, but what is it that really will make lean come out alive in companies? And the real basis for lean always has to be the employees. And so lean is all about empowering employees, and simply saying that management needs to get out of the way of the employees is not enough. Management needs to be involved in creating and working with a workforce that is disciplined and that is wanting to do the things that are needed to be done to reduce the complexity and improve the processes if lean is to really benefit a company. And like the author of this book that I'm showing you, Liquid Lean, has said, the most difficult thing that a manager will have to do is to undertake empowering their employees and making them the best they can be for the benefit of the company. Here is kind of a table that I would like to talk about, and this table is from the book, The Machine That Changed the World, the report on lean that I initially mentioned. Now, I'm not going to go over all of these numbers, and you can look at these numbers later, but one number that I would really like you to look at is the suggestions per employee. So if you look at here, it's in the very center here, the suggestions per employee. So in fact, if you see here, suggestions per employee. Now, suggestions per employee for a company in the US, a Japanese company in the US is around 1.4. If you can see here, if I can get my laser pointer, yeah, 1.4. And then if you see for American companies in America is 0.4, European companies in Europe is 0.4. But the suggestions per employee in Japanese companies in Japan, if you can see, it's close to 62. Now think of that for a minute. Each employee is making 62 suggestions per year to improve the process, whereas others are doing in ones and halves and things like those. And what an effect that would have. Now to get to that level, tools are not enough. You have to also create a culture and really empower your people to make that happen. And like Toyota says, well, everybody has access to the tools. You can have all the tools that we have, but one thing that companies cannot really get is the culture that they've developed. And these companies who have been pursuing lean for a long time have had a head start of 40, 45 years by developing that kind of a culture that makes them that efficient. Okay, so going a little deeper into the whole concept of empowerment, Absent a clear and shared understanding of the strategic intent of the business, frontline teams can get lost in the implementation. And I make that statement because here's what happens. If the management is not truly involved in a hands-on manner with the front lines, then eventually they will get lost and they will not know where to kind of go ahead. A lot of managers kind of, I've heard them say, oh, I just get out of the way and let my people do their job. That is not a good approach to managing these teams, which will really make the company more efficient. So senior managers spend a lot of time talking about sports and weather, but not about ideas to improve the business. And the whole concept of lean here is senior managers need to take the lead and take it upon themselves to not just talk about things that do not matter, like the weather and sports and things like those, but also need to be involved in how to improve the business and how to take the business to the next level. And here is a quote from the same book, Liquid Lean. You will never receive a person's second good idea until management has done something about the first one. So you have to create in the lean environment a way that you take people's ideas and really do something about it. And then you will start getting the second, third, and the 60-second idea, like we saw for Toyota and for the Japanese companies. So I guess some of my closing thoughts here, it is not necessary to change. Like Deming said, survival is not mandatory. And we are what we repeatedly do. Excellence then is not an act, but a habit. And that was said quite a few years back by Aristotle. And like Gandhi said, live as if today is your last day. So put in all that you have into your day, but learn as if you're going to live forever. So with that, I'm going to close my presentation, and I hope we have time for interaction. So if you have questions, please go ahead.
Thank you, Dr. Mehta. That was an excellent final quote from Gandhi. Excellent. So at this time, we have plenty of time to take any questions anyone might have specifically for Dr. Lee or Dr. Mehta. If anybody wants to jump in, unmute yourself, ask questions, please go ahead. I'll give everybody a few minutes. Okay, maybe not. Okay, well, if anyone thinks of any questions, please shoot me an email at sustainabilitycenter@ecu.edu. Again, I would just like to thank our speakers for being here and giving us your time today to share this information on lean methodology. Our next event in the pollution prevention series will be on November 4th, again from 3 to 4 p.m. Eastern Standard Time. Our next topic is to be determined, and just mark your calendars for that day and keep on lookout for an email from me with registration information and any further information. Again, this recording will be available in a shared OneDrive. Due to institutional restrictions, you will need access to request access from us to be able to view that folder. The presentations will also be in that folder as well. Everyone should have the email at this point, and you can just respond to that, and I will be able to grant you access to that folder. So otherwise, if no one has any questions, we'll go ahead and close out for today. And again, from the center, we hope that you have a great, safe, and healthy weekend ahead. Thank you so much for joining us today.
Thank you, Kara, and thank you, Dr. Mehta.
Thank you. Thank you very much.
Dr. Lee, Dr. Mehta, well done. Thank you so much for your time and energy.
Oh, you're welcome, Dr. Lesko. Thank you much. Thank you for coming.
Yep.
Thank you.